Good afternoon. Welcome to the session Big Data and Analytics for Manufacturing Operations. My name is Bart. I'm the EU Control Engineering Manager for Amazon Customer Fulfillment. And I'll be taking you through what we're doing within Amazon Customer Fulfillment with data gathering and pushing it into AWS data lakes. So the scope of this talk, what I'm involved in within Amazon Customer Fulfillment is the physical side, so Amazon Logistics, Amazon Fulfillment, not the website, the Amazon.com or Amazon AWS. So I want to focus on what we're getting out of our machines and what we're doing there to optimize our supply chain. So the outline here is what we're doing with the designs, fulfillment center design. Then I want to touch on our equipment design, what we're talking machine as a service, and also the AWS technologies that we've used there. So what we're looking at within customer fulfillment, we're looking at 3 levels. So we've got machine sensors, actuators. Usually that was a big, rigid, monolithic design. Didn't help us with getting data out of it or integrating it with AWS. On top of that, we had warehouse control services, local servers mounted in a data set within our facilities. And above that, warehouse management services, software running in our data centers, rack-mounted data center hardware. What we're looking at for the new design and what we're rolling out in our fulfillment centers is a more modular design at the low level. So we want to look at machines as commodities. We just want to be able to buy them from any number of manufacturers. We want to be able to swap them out for new machines, or if they need to be replaced with other types of machinery. It's a bit flavor of the day with packaging designs. So a lot more modular design. The local software still remains in local services, local servers, but we're looking to use more AWS green graphs for that. And then on top of that, our warehouse management systems, they're all running in AWS. The design that we're looking at, that we're rolling out, is based on ANSI ISA S88. It is a batch control standard, but it applies to discrete manufacturing or continuous manufacturing as well. So on the left-hand side, we've got our enterprise, Amazon Customer Fulfillment. That leads into a big tree, so sites, site A, B, how many you have. That goes into areas, into process cells, and units. So it all dives into more and more levels of detail, and that granularity allows us then to extract data and start analyzing that at high level. So what does it look like for a modular design for one of our fulfillment centers? We start at the top with a receive router. Then we've got Amazon Robotics in there. You're probably familiar with those systems. So it might be 3 levels, might be 4 levels. But using the modular design, it doesn't really matter how many you have. As long as the red blocks that you see, they're the unique bits, and they're the ones that we copy-paste. So we look at those, we start a template, we start a typical for those, and it doesn't matter anymore how many of those typicals you copy-paste. We can fulfill our designs in that way and perform to capacity. So with that equipment design, we've had to go to our system integrators, and they needed to get a mind change there. They were used to designing machines in a very monolithic design. We asked them, look at specific functions, look at a unique machine, and start developing that as a commodity, that we can say we want 20 of those or we want 40 of those, and just chuck it out like a central unit. What we want as well is integration of Industry 4.0, Industrial Internet of Things, creating smart factories there. So we want to get more and more data, but we also want to control our machinery. And that control of machinery is also a mindset that hasn't reached machine manufacturers. So if we look at the data and we think it's better to switch off a machine or speed it up or slow it down, we want to be able to do that from our AWS services, because that's where the brains are, that's where the analytics happen. For us, it's evolution. It's not revolution. It's not going to be, okay, this year we've built them in a certain way. Next year it's going to be all big, all good, everything works for us. It is an evolution. We want to have small step changes. Manufacturers aren't used to this. So they need to start changing their equipment design, their way of working, and we're helping them get to that way. So machine as a service for us, how we've defined that, it's not industrial Internet of Things. There are differences. Looking at equipment life cycles, I've been in the industry about 20 years. I've worked with machines that are older than me, and I know that they're still in operation. So if we look at the life cycle of a machine, we need to support that 20, 30 years from now as well. Cloud connectivity issues, we know cloud isn't always available. We want machines to run even though that high-level connectivity isn't there. So the machine needs to be designed in a way that, yes, it gets information from the cloud. If that cloud connection is severed, it still continues to operate. Maybe not as good as it used to do with the cloud connectivity, but you can't have it not run because your connectivity is down. But also security. If we're looking at industrial control systems, security is not what they've looked at from the start. So PLCs that we're using Siemens. The design has come from 1985, and that internet connectivity wasn't even a topic yet then. So security needs to be a consideration in this design. So what AWS technologies are we then using? A simple one for us was introduction of AWS IoT buttons. So we've put these on machines as add-ons for associates to call some of our troubleshooters. If they're running low on equipment, packaging material, or machine fails, push the IoT button and the text message is sent to an engineer. So this is one of our machines. As you can see on the right side, it's a label applicator. So if you put an order into Amazon, your box goes into this machine, it puts the shipping label on with your name and address, and it verifies if that is correct. And then that's where we put it. So IoT button next to it, the operator can call for assistance from one of our water spiders or an engineer. So the water spider helps them getting shipping labels or if there's any other issues, and an engineer if there's a malfunction with the machine, so one click or a long click, and the result of that is a text message goes to the right person. What we used to have there is an add-on light. So the associate put a light on, might be amber, might be red. The water spider sees the light, walks over, talks to the associate then tells, okay, I need packaging material or I need an engineer, and that took a bit more time. With this, it is a direct message. You get a much quicker response. Amazon Kinesis, we are trying to put a lot of data into Kinesis. I think Dario is going to go into more detail on how we use that for analytics. But again, that shipping label that we put on, there is a barcode verification on it. So we make sure we put the right shipping label on the right box. That information is augmented with units of measure. So how tall was the box, how heavy was the box, and all kinds of measurements. And that goes into AWS IoT through a Kinesis stream, and we then extract what is the read rate of my machine. If the read rate falls, then it could be an issue with the scanner, the camera that's looking down at the box. But AWS Kinesis allows us to do a lot more of that analysis. We've got sorters, so this is a simple sorter for us, a loop sorter. We've got several inducts, we've got outputs, and again, barcode scanners on there. Quick view of it. You've got motorized carriers that can divert your packages. Big control panel, so big industrial control system there, and we're getting a lot more data from that because we want to start measuring a lot more. Power measurement is one of the things that we're looking at. So does it make sense to run a machine at high speed when you don't need to? So if your packages, the rate of that is much lower. And that's where we're trying to optimize our energy usage. Looking at a diagram of it, you've got your loop sorter. We're measuring with the barcode readers, again, the read rate. So how many packages is it reading correctly? Do we need to increase there? We've got power consumption that we're measuring. We've got data coming from the motor, motor currents, the speeds, but also vibration monitoring. So we need to start looking at how are we loading the sorter, and is that affecting the vibration? Is that affecting the current that the motor is drawing? So all of this, we're trying to now push into AWS, and that data, the analytics, that's where Dario is going to pick it up.
All right, thank you, Bart. So before I get started, just so I get a lay of the land and kind of figure out how low level, high level we are here, who actually have an AWS account that they're using now? Quite a few of you. All right. Who are actually building analytics platforms on AWS for dashboard and analysis and visualizations for some of their pipelines? A few of you, so that's good. All right. So one of the things that we saw from Bart's presentation is a little bit of sort of the art of the possible associated to some jimmy rigging of a lot of existing older kinds of applications or processes being fit into now being able to collect the data from many of these manufacturing devices and bringing them to the cloud so that we can get a better understanding of what's actually going on in our overall process of manufacturing. I do this a bit when I talk to some of my customers when they talk about pharmaceutical manufacturing and how they assure that yield is coming out correctly from one geography over another, or when they want to optimize their yield associated to their packaging of things like pill capsules and stuff like that. All of that is very, very important to assure that processes are first understood very clearly, and then finding out how to optimize them successfully to just tweak whatever parameter they see as an issue, and therefore their yield becomes much more than what it was before. So what we're going to do now is sort of talk a little bit about, take a higher level view of things and get a perspective on what are some of the ways that we think of how data is brought into the cloud in macro from a manufacturing standpoint, and what are some of the common patterns from an architectural perspective we should be thinking about when building pipelines and building analytics platforms and eventually building dashboards that give you the insights to your processes to understand how to make the business decisions necessary to increase the level of optimization and control that you have over the manufacturing processes you have. So what we see here is that we're taking some of the traditional methods that are associated with manufacturing and trying to put an observer on them that will then be able to collect data and bring it into a common source to be able to do analytics on it. So what are some of these edge data generators that are commonly thought about? Well, we have the processes themselves. We know that's essentially a conglomerate of a lot of different manufacturing devices that are working together to produce an object. Along with that, we have the employees, the people that are evaluating these processes to assure that they're running successfully. And we're looking at the activities that these employees are doing on a regular basis to, first of all, identify, are they doing the right ones? And if not, how can we modify these activities to assure that they're meeting the needs of the overall process that's being produced? And then obviously the equipment itself. We know that for manufacturing, there's massive amounts of equipment, and all of them have difficult ways of being analyzed to assure that you're getting the utmost efficiency from it. There may be an issue going on with a piece of equipment that's part of a 100-step process that you don't know about until it goes bad. Imagine if you were able to, for whatever way that you can, jimmy fit a telemetry collector onto that device to be able to analyze what's been going on at a higher level and get warnings maybe months in advance of something going on with that device and be able to do something about it, change it out or fix it so that you no longer have an issue with your process. These are the kinds of things that we see the IoT industry going into, and what we'll talk a little bit about more. So all of that is fed into the applications running in the cloud, running on AWS. And we'll speak a lot about, obviously, the value of the cloud. It's highly available. It's always on. You know that you're going to get kind of API-driven interfaces behind it so that you can really have any kind of application or other device sort of connect to it. All of this is associated with increased innovation, because not only are you now innovating off of the processes that have already existed, but now you have the ability to gain insight in these processes in ways that you've never had before. And that will allow you to possibly modify the existing processes, or maybe think of new ways of changing these processes altogether to still produce a more higher quality product than what you probably had previously. And all of this, again, at lower cost. And we know that that's a big driver associated to innovation. We can really do anything, and you have to ask the question, how much time is it going to take and how much money is it? And so with that, as we see customers thinking about the cloud use, specifically in manufacturing, we see that cost drivers are becoming much more of a higher factor, and because we're seeing that they have the ability to do things that they never thought possible before. So with that, we look at how there's sort of an external focus also associated with how you can take a lot of the data that's being collected in the cloud, the processing happening onto it, and now have a more external focus. Imagine having the ability to take a lot of the aggregation of many different data collection sites within the processes of the manufacturing and be able to combine them together so that you can see in macro where there may be patterns that you wouldn't be able to recognize before. Geography A site, geography B site are both producing the same product. For whatever reason, geography A seems to be producing at a higher yield than geography B. They were built and engineered to seem to have the same exact processes, the same exact steps, but something is different, and I can't figure out what. And knowing that you have the ability to aggregate these two geographies' data together to be able to come up with fine-tune analysis on what might be going on is really what the cloud allows manufacturing processes to do. So we look at what's going on with the business architecture aspect of it. We notice that it can be much of what the cloud can offer is being able to ingest data coming from the manufacturing plants and via some of the processes that we're going to be talking about in detail, such as ingestion and real-time processing and batch processing, machine learning, voice interaction. You'll not only have the ability to get a globally monitored dashboard, which I kind of alluded to in my previous description, but also now be able to do predictive maintenance. You're able to see trending data associated to one step or multiple steps in macro occurring on the data. It used to produce at this yield 4 months ago or 3 years ago, and now we see a slow degradation in the way that things are being done. And as such, we can apply predictive analytics to that to identify how far is this going to go down based off of the rate of change that's happened previously. Is it going to get to a threshold within a certain period of time that we know that we have to take action? And how much time is that going to be? And what kind of action is necessary? That's the kind of power you get from, first of all, the data ingestion that's coming into what the cloud can offer, but also the AI capability that you can put upon it, the machine learning capability that you can put upon it to really get those kind of insights that I just talked about. And that leads to more finer-tuned quality control, knowing that you have very, very, very clear and concise ways of looking at the data based off of your standards that you define to assure that you know or that you can try to build the highest quality processes possible. And then that eventually affects the maintenance. Now you're making actual physical business decisions based off of that data to determine how to make your business run more efficiently. We also see that this can be now pushed out to the edge even further, where not only are you handling or making business decisions that are associated to the processes themselves, but imagine being able to have some of your end customers get insights into what's going on with the processing, depending on the type of product that you're producing. And then they can feed into the quality control that you're assessing. I was delivered the product as a customer, and after 3 months of using it, it failed in so-and-so way. And that is now fed back into the analytics environment to determine, okay, we're seeing trending for the same kind of problem happening to this particular product, and it seems to occur for a batch of products that were delivered to customers at this period of time. What actually happened in the process that was producing that defect? Well, let's look into it a little bit further. And these are the kinds of insights that are really, really powerful that were very, very difficult before to kind of get a handle on. So this all comes under the higher paradigm of what we call a data lake. And data lake has a lot of definitions, and depending on who you talk to or what website you go to, you'll see many different variations to the definition. The way we like to think of it in Amazon is a collaborative environment that you're allowed to aggregate data from many, many different resources and be able to take not only the raw data that was ingressed into that environment, but also be able to produce iterations of data sets associated with that raw data, eventually to get to the analytics associated with the definitions and the patterns defined in that data to produce decisions that allow you to make change. That's a long-winded definition, but it really reflects just sort of a consolidated way to get data and get answers from that data. So what that means is that you can collect anything, regardless of the structure of the data. You can dive in anywhere in that collection. You can have flexible access in terms of how to gain control over it, how do you want to use it, and it's also future-proof, meaning that as new technologies are being produced, that they can work with data that was produced 12, 10, 50 years ago and still be able to do something valuable with it. So what we're going to be talking about today is a little bit about how we can build out an architecture that can exercise all of these characteristics. So components of data lakes sort of have four major components, four major categories of implementation. Obviously, you only want people to be accessing the data that are allowed to be accessed. And you want to make sure that they're using it in the way that they're supposed to be using it based off of defined compliance structures that you as an organization define. You also want to assure that you can ingest and store from anywhere. You have the ability to bring in data from many different access points and assure that it's stored in a way that's easy to get to. One critical component that sort of changes the game associated to what we commonly think about a data lake is catalog and search. Essentially giving you a marketplace for data sets where based off of the metadata of the data that you're collecting, you're able to put in keywords as a search component and be able to see a catalog, very much like Amazon.com, a catalog of data sets representing aspects of the search term that you used. So imagine you go into a website and you're typing in things like clinical trials, in my case, clinical trial data sets. And now you see 50 different result sets representing of data sets that are being kept in that data lake. And as you add more search terms, those data sets become less and less and less to get to the ones that you think represent the highest value. You click on one of those values, or one of those data set records, and you see a whole description of what that data set is about, as well as maybe a little bit of the history associated to where the data set came from and who's used it and what they used it for. And these are the kinds of things that are commonly coming up as part of the definition of data set that we are helping our customers build. And then, in the end, it's protection and security. Obviously, you don't, this is highly sensitive data. You want to make sure that it's only being used in the way that you define and assuring that it's not getting out in any way other than what it's supposed to. So all that being said, it all starts with S3. S3, whatever the question is, S3 is typically the answer. As you know, S3 is a highly durable, very, very flexible way of holding data, securing data, providing access to data, and assuring that data can be delivered in many different compute environments that eventually do something with that data. With that, you have data ingestion that is now pushing data into S3 from many different sources. We'll talk a little bit about some of the specifics of the characteristics of the services we mentioned here: Kinesis, Direct Connect, Snowball, DNS. There's actually many others. But all of these are essentially ways of either creating data or gathering data from where the data is actually created and then transferring those into S3 as a raw format to be done with something later. Then you have the other side of the game, which is being able to do something with the data that came from that data ingestion stage. Being able to take that data, maybe do ETL against it, to turn it into a form that is actually useful for asking questions against. Or maybe combining two different data sets together and then doing ETL against that. Or putting it into a compute environment that you're allowed to query against, do batch analytics, or possibly even doing visual analytics, where you have some visual third-party solution, or maybe even an AWS solution that gives you the ability to see things from a visual standpoint, do trending data analysis, doing machine learning against that data. All of that is representative of that processing and analytics. The catalog and searching we already talked about before. Some of the major components associated to that is being able to host metadata of the data sets that you're hosting in S3 into some database and allowing the ability to search off of that database of that metadata collection. And then access and user interface, assuring that you have proper ways of collecting the users who should be able to access your data lake, providing permissions onto those users to granularly define what kind of access controls they have, and some level of logging to assure that you can get very, very fine-grained understanding of what each of those users are doing as they're accessing your data lake. And then from the other side of it is the compliance standpoint. Across the whole kit and caboodle related to the data lake, what's actually going on. Not only am I collecting all the activities that are happening in the data lake, but I'm also assuring that I can do searching against all the collection of that history. And if there is a breach, if there is a accidental misconfiguration of the way the data was being used, or maybe there's a legal requirement associated with understanding how that data was accessed, you now have the history to be able to ascertain how to get the answer to that question. So all of this sort of reflects what we call a reference architecture. And as we look on the sort of ingest aspect, we know that it starts with sort of these physical components. These are the devices that are at the edge where action is actually happening. In Bart's case, it was the supply chain process itself. And as packages are being packed up and then labeled and finding a way into a truck and being delivered, all of that is data that needs to be collected so that it can eventually be analyzed in some way. And so when we look at data analysis platforms, we recognize that there's a whole history in terms of how data has been used in the past. Warehouse appliances happening in silos where you need to have them in a specific structure. They stayed there for years. They were difficult to work with. And there was no way that you can collaborate any other data against the data in that data warehouse without a lot of work. And then Hadoop came along and made it a little bit easier by making data more flexible to work with. It was scalable in nature because of the nature of the node-based clustering mentality of Hadoop and all these open source tools being put upon them for more and more innovations. EMR, decoupled EMR, where now you have the ability to host data in S3 on AWS, where you can put all this raw data and then have clusters come up as on need, where you can do sort of these batch processing jobs that happen, and then they shut down, your results get stored in S3 in another bucket, and then follow-on analysis could happen later on. So you're really getting cost efficiencies out of these ephemeral clusters. Redshift was able to take that to the next level with really, really high-end processing and taking a lot of the values of cluster-based computing along with some of the historical aspects of value that came from traditional data warehousing and bringing it into one comprehensive whole. And today we have Glue, which gives you on the fly ETL, managed ways of manipulating data, as well as Athena, which allows you to store data on S3 and then query directly against that cold storage without using any compute at all. So how does this all fit into our main reference architecture that we talked about previously? So we look at, on the serving side, you take a lot of the components that we talked about previously, where you sort of get these ephemeral compute environments that give you the ability to find answers quickly and turn them into the categories of delivery that fit your organization. Some of these are data scientists who really want to play with the data, really want to understand how to work with some of this raw data that's coming out of some of these original physical components to get a better understanding of, first of all, how they're collecting that data, how the data is structured, how they can manipulate it, how they can play games and do experiments against that data to produce, just trying to evaluate what are some of the questions that can be asked. They're not necessarily looking for answers yet. They just want to get a better understanding of some of the questions. And then you have the data analysts who are really kind of understand the question that they want to ask, and they just want to find a faster way of getting to the answer to that question. Maybe it's through a curated environment that you're constantly delivering new data to it, and they are able to run a report either immediately or in batch, get a result, put that into a report, send it to a stakeholder, and they move on to their next challenge. You have business users themselves. You think of sales folks who may be trying to sell your product, or maybe are a third-party vendor that is producing a hardware component that's part of your process, and being able to deliver to them some of the capabilities associated to how their device is working within your process is something of value to them so that they can better serve you. And then that eventually turns into engagement platforms where we think about having multiple business domains interacting together associated to different ways of sharing that data. So business domain A, business domain B traditionally have been collecting data for years. They never really talked to each other. They didn't even know that one was somehow being affected by the other. And until you brought this data in and the data scientists started messing around with how to manipulate the data in such a way to show both teams how they can produce value for each other, none of that was possible. And it's allowing for higher levels of efficiency in enterprises and giving them capability of insight they were never able to see before. And then we move into the automation and the event processing, and we'll actually show you a implementation of that via something that Bart did at the end of my presentation, where you're able to, as we saw with the dash buttons, and as we look at folks like Tetra Science who have built IoT devices that connect to actual older physical machines and be able to now make that physical machine an IoT device. What this means is that they're able to send events to the machine to do something, to make that machine do something, or vice versa, collect data from that machine, pass it to the cloud, which is somehow eventing a process to do something further on of value. And so all of these sort of use cases represent what the serving and the compute capability that AWS brings to the table offers a manufacturing pipeline. So what about some of these other spaces that we talk about underneath the scenes? What are they, how are they used in terms of filling in that whole comprehensive whole? So we think of, for instance, S3, and I'm not going to go into the values of it. Most of you are already using it or have heard about it and know all the value proposition associated to it, but I can't tell you how critical the proper use of S3 is in the concept of data lake and really process manufacture automation and optimization. It is the critical spine that allows everything to flow smoothly. And without assuring that not only you're hosting data in S3, but you're allowing the proper levels of control to assure that only the right types of access is being provided, but also making sure that when you build data on S3 or host data on S3, that you're using some of the best practices that we talk about in our documentation and other talks that you've probably been listening to that reflect that you're getting the most optimal use of S3. That when you're asking for delivery of massive amounts of data or hosting massive amounts of data very quickly, that Amazon can do that for you effectively on S3. So we see that S3 is a critical component to serve the compute platform where all the analytics and questions are being asked against the data. Then we have data ingestion. And what this means is, of all those physical devices that we talked about on the left, or your right, how does that get into the cloud? There's many, many different ways that Amazon offers. There's many ways that third-party vendors offer. Essentially, they have S3 API connectors that somehow get that data in there. Direct Connect is a private connection that allows you to use your on-prem environment and your existing network and connect it via a private line to the AWS cloud in a 1 gig or 10 gig connection or multiples thereof. Kinesis Firehose is a way of allowing you to apply a consumer or data consumer application that is communicating with the host devices and putting them into a scalable stream of data. And that stream of data allows you to not only push that data on an as-needed basis as data is streaming into a data collector that's now hosted on the cloud that you can do some analysis with, but what's interesting about Kinesis itself is that if you want, you can do analytics on the stream itself. It takes sampling of different messages of the stream and allow you to ask questions of it. It gives you insight into what the structure of those messages look like, and you even have the ability to say, how often am I seeing this particular value? Or if I am seeing this data in aggregate, am I noticing a trend? That's something that Kinesis Analytics offers to the table. You have S3 transfer acceleration, so it allows you to use the Amazon backbone and be able to transfer data directly to the edge of that backbone that is not the actual regions in which most of the services are hosted, and now use the Amazon backbone to get your data to Amazon a lot faster. As was mentioned before, you have a lot of third-party connectors out there that, depending on how you collect your data, can move data in batch or also in streaming. Storage Gateway allows you to put a virtual device on your premises and slowly aggregate data into the cloud. And then Snowball, if you have a totally disconnected environment that has no connectivity to internet or very, very low bandwidth, you can actually have Amazon deliver you a server, a hardened server, that can survive explosions and host up to 50 terabytes or even 80 terabytes of data at once on that Snowball device and get that in batch into Amazon. And you can order as many Snowballs as you like. As a matter of fact, you can host code on what we call a Snowball edge, an actual physical device, and have low-end processing occur on the data that you have in that Snowball as it's being transferred in transit back to the Amazon cloud. So we see that that represents the ingest portion of our reference architecture, which is taking all that physical data and somehow getting it to Amazon and into the Amazon platform. So now we talk about building your catalog. If you do not have a catalog that you can search, your data lake is a data swamp. It's a place where you host data that you know nothing about and it's hard to get to and you probably won't use it. Or you'll use it the wrong way. Or you'll have to ask somebody to tell you how to use it. So building a data catalog is critical to the success of a data lake. With catalog and search, you want to be assuring that you have some sort of compliance framework in place that represent the proper way of hosting metadata for that data set you have in your data lake that is applicable to your enterprise or your specific domain. That means that if you have a data set that needs to go in your data lake, it needs to have a minimal amount of data, metadata necessary to explain that data set correctly. So here's sort of a small reference architecture representative of how you can build a catalog and search capability in a serverless manner on AWS. You're putting metadata records into an S3 bucket. You're eventing that metadata record via a Lambda function that then hosts that record into a Dynamo database table, which then does another event, which kicks off another Lambda, which then now indexes that to an Elasticsearch. Very, very simple, but very, very powerful. Without this minimal capability, again, your data lake is a data swamp and is very, very difficult to work with. So that fits on sort of the top level, and as you see, it's sort of overarching with everything else that's going on within your data lake. Now we talk about having the proper security controls, and this is sort of representative of not only how you isolate and control access to the data hosted in your data lake, but also the people using your data lake. And without this capability, there's a lot of open holes that obviously, if you know, represent kind of bad things going on within the data that you want to do something really valuable with. So obviously, you want to make sure that you have encryption in place. The nice thing about S3 is that when you host data on AWS, all you have to do is turn on a switch, a simple configuration, and all your data hosted within that bucket is assured to be encrypted. And that encryption can be a key that you provide Amazon or a key that Amazon provides for you. Then you have identity and access management, essentially how to lock down users of Amazon. What we see many of our customers do is actually build their own versions of identity and access management. What you don't want is taking a lot of your existing users that you may have in a different domain, such as Active Directory or other ways that you manage your data or your users, and trying to replicate that as AWS users. AWS has a lot of ways of connecting with existing user domains and ensuring that you can still provide the group policy necessary on the AWS services so that the users are only accessing the services in the way that you define for them. And then audit and compliance. How are you making sure that you validate what is going on with the users and the use of the data in your data lake, and how are you ensuring that you can audit that you have the evidence necessary to gain the benefits of what is actually happening within your data lake. So identity and access management is one way, fine-grained control via something that Amazon provides, as well as KMS, CloudTrail, and CloudWatch. You want to be using a number of different security services that either are out of the box of Amazon or based off of your specific security needs that your enterprise defines. You may be already using a third-party provider, or you may be researching a third-party integrator that will provide that level of control that you're looking for. We can't say there's one size that fits all with security because that never happens. Everybody has a different approach to how security occurs that is unique to them. What we're doing is assuring that you keep it in mind and giving you some of the base services that AWS offers. So along with that, we talk about how data is brought in batch in S3 from your ingest stage and then moved to EMR. We also talk about stream analysis, where you have the ability to not only see data coming from your physical devices, but then feeding that into an analytics platform. Again, this is representative of first doing a translation of the data into a way that's easily consumable by your compute environments, and then feeding that into your serving environments to allow for compute to occur to produce the results that you're looking for, either from a report standpoint, a visual standpoint, or simply scientific research. And then we also talk about some of the aspects of machine learning, which are critical. You'll see as part of this conference that Amazon is going to be doing a lot with machine learning and AI, not only now, but as we think about the push toward the future. A lot of this is representative of assuring that even folks who may not have machine learning as their expertise, they can still get the benefits of what machine learning offers. And so Amazon is coming up with lots of innovative ways of removing some of the hard stuff about AI so that all you have to do is make simple choices and get really, really high value from the data that AI is analyzing. And you'll hear some very interesting things coming up in the near future. So one of the things that we try to help people, steer people to is we look at this reference architecture. This is really complicated. There's a lot of stuff going on here. Do I have to build all of this myself? Yeah, AWS brings all these Lego blocks, these really interesting services, really high power, but there's a lot of connecting that needs to go on here. Is there something that I can do to get me ramped up faster? And so the solution builders team has produced what's called the AWS Data Lake Solution. Again, all these slides will be available on slideshare.net. You'll see YouTube videos against this all as well. You can just type in Data Lake on AWS. You'll get to this site. And what it is essentially a CloudFormation script that you can bring into your account and do a lot of the things that reference architecture I just mentioned does. It builds out a scaffolding of a platform for you that allows you to have a serverless data catalog and search, as well as giving you the ability to easily consume data and put it into compute environments so that you can get to where you need. And the nice thing about it is that the code is all open for you. And so as you provide this to your developers, or maybe you're a developer yourself, you're able to manipulate a lot of this reference pattern to conform to some of the standards that your enterprise needs for its own data lake. So again, just to assure that we do a review here, everything starts with S3. Whatever the question is, S3 is the answer. You have data ingestion as one aspect. You have processing and analytics as the output of the data that's coming in. You definitely need catalog and search for control over how you get access to the data and making quick understanding of what data you have, and then assuring that you have the proper level of controls against that data lake itself. And obviously everything being protected and secured and auditable by some of the core capabilities of security that AWS offers. So here's a little video representative of the art of the possible. This is something that actually Bart made. This was one of the devices that he was trying to get insights on and be able to automate a little bit effectively. And as you see here, you have a small little Amazon Echo on the side there. It's not connected to anything except the internet. And then you have an IoT component that's attached to one of the devices, and we'll see something special happen. Hopefully we'll get the video working here. Can I actually do it here?
Alexa, tell pump to turn on.
Turning pump on now.
Alexa, tell pump to turn off.
Turning pump off now.
All right. So I like to think of this as like, imagine I'm an old dude. Star Trek The Next Generation, you had Geordi talking to the warp core and asking it diagnostics of itself and telling you to change the configuration to make the whole ship run better. This is sort of the art of the possible to get there. You start out with something small, but as you can see, as we get more and more powerful ways of connecting some existing devices to the cloud and be able to do some interesting things in the cloud based off all the services AWS offers, we know we can get not only fine-grained control over the insights of our existing data process or manufacturing processes, but even possibly being able to change those manufacturing processes to work even better. So that's it in terms of the presentation. It's about 13 minutes and more of time that we have, so we're open to questions for either myself or Bart associated to anything you heard during this session. And the mics are there if you want to go to the mics and ask questions.